So determine the terminal voltages VB, VE, VC of each transistor with respect to ground for each circuit. Also determine VCE, VBE, VBC, IB, IE, and IC. Assume alpha DC is 1 and beta DC is 50. Okay, so what do we know? We have VBB here, which is 10 volts. Now, there's no loss of potential here, so it means here at this point, which is B, we're going to have 10 volts. So that's first. We know VB. Then what do you know? You know that across here, that little arrow here is a diode. So across the diode, you always have 0.7 volts. So if I have 0.7 volt across the diode, at this point here, which is called E, I'm going to have VB minus 0.7 volts. So VE would be 9.3 volts. Okay? So now if I know VE, okay, VE here, and this is, remember, the ground, so I have 0 volts everywhere. So if I have 9.3 volts at this point, and I have 0 here, the voltage across RE is also going to be 9.3 volts. So if the voltage across R is 9.3 volts, then IE or IRE is the same, in that case, is going to be 9.3 over 10,000. Okay? So 0.93 milliamps. Now, we assume that alpha DC is equal to 1, okay? So if alpha DC is equal to 1, it means that IC is going to be equal to IE, 0.93 milliamps. Yes? Okay? So it means here I'll have 0.93 milliamps. Now, what's the voltage at this point? Voltage at this point is the same as VCC, so at this point you're going to have 20 volts, so VC is 20 volts. Okay, so between 20 and B, so VCB will be 20 minus 10 volts. I'm losing 10 volts across CB. Across CE, we've written here is always the same. Across B is always the same, is 0.7 volts. So across the entire resistor, which is CE, I'll have 10.7 volts. The last thing we are missing is IB. Now IB is going to be IC over beta DC. Okay, beta DC is 50, so it's 0.93, 10 minus 3, over 50. So IB is going to be very small, minus 3 divided by 50. 1.86, 10 minus 5 amps. Okay.